Good morning,
Yeah.
Hou Chenzhong. Again, fantastic. I think we need
Is it
another.
working?
I think we need another toy at this point.
Yeah, it's this one, OPZ, and this one is OP1. Where is the third one? And let's go back to the future. I'll go back to some.
So
So
this is something that was around when I was growing up. This is a rock and play tape deck,
yeah,
and like, how would you use that? How are you using that right now?
I just put a tape into it. I'll record a chord. It's very long, and I have some endless tape, so I can use it as an ambient, and I slow down the tape.
Cool, because
The texture.
it's got a pitch control on it.
Yeah. It's here. The speech control, the speed control, and the volume control, and also you can output to some pedals like the big sky, and it sounds just nice.
Awesome. When I was growing up, this was actually a tool for you would play screaming fast metal guitar, right?
Shred.
And you would but you would want to learn these very fast guitar licks, and so you would put the cassette into there, slow it down so now the guitar licks were a little bit slower.
Yeah.
And you could learn that.
Yeah.
Great. Well, I'm gonna do a quick introduction. Welcome to Wwise Up On Air. We were muted there in the beginning, but it's great to be here today with you. At Audiokinetic, we do these series of episodes, live streaming, hands-on with developers, and I'm joined here today by our Audiokinetic product expert, Hou Chenzhong. And we're going to be talking about some cool stuff that you've been doing with Unity and Wwise, and a couple other fun little plugins and noisemakers that you've made for a virtual experience or for an experience that you have in Unity.
Yep.
And we have a little special guest coming up. So with that, I'm going to transition you to this presentation, and we'll kind of get the show on the road. But first, why don't you tell me a bit about what you're up to in China as a product expert for Audiokinetic?
Okay. Before I worked at Ubisoft Shanghai studio, and I worked there for 3 years, and worked on maybe Just Dance and Far Cry series. And after that, Wimbo, which is a country manager, he hired me and as a product expert, and I worked here until now. It's 1 year already, and sometimes I do technical support, and sometimes I will go out and to do some tech showcase to customers, and maybe I will go to the customer's company if there are some serious problem and I have to solve it. So it makes the customer not that anxious, right? And because we take responsibility.
Well, and this is a role that I played as a freelancer for years, of just trying to help people through some of the technical challenges that come along with implementing sound and technical sound design. And so I know that feeling of being a developer or helping a developer who is just looking for a solution or looking to get unblocked. And so it's really valuable to have someone with your experience dropping in, helping people out, and again, sharing that creative collaboration of game audio. Great to have you there. And I was glad to have got to meet you in person in Montreal last year, soon after you joined.
We had some poutine
and some bakery, and it was fantastic. Glad for that, and also glad to have you here today. So,
you too.
Thanks for joining us. Let's talk Wwise and Unity.
So now I think the audience can see my screen, right?
Correct.
Okay.
We gotcha.
So the title is Wwise plus Unity plus PD plus Heavy plus OM craziness. So it's a lot of plus. During I think during last several months, I worked on a demo project which is for the China GDC, which is a game developer conference, because I need to do some presentation like how good Wwise is, right? Because I worked for Audiokinetic, and I collected a lot of questions like, can Wwise do it? Can Wwise do that? Because customer maybe want to implement some design. So I collect them, and I've already read a lot of blogs. So there are some amazing games, has amazing feature on sound. So I want to put all of this crazy stuff into my demo. So it's like answer to customer questions like, can Wwise do it? Okay, Wwise can do everything.
Well, and what a great way to like build this demonstration as a show and tell to be able to illustrate this for folks. And thanks for sharing it with us here today.
Yeah, you're welcome. So in the demo there are 4 areas because it's like 4 levels. And the first level is about spatial audio and the spatialized music, because music is sometimes played as 2D, and but you can play it in a 3D space. And the second area is for memory categories, because in this area I can like press one button and build 100 cubes, and each cube have a sound, and they all have Doppler effect.
Yeah.
Because it will calculate the pitch changing factor, right? So it's costly, and also I enabled the diffraction and the reflection. So how to optimize it with our newest profiler system?
Yeah.
So it's what this area is for.
Fantastic.
And the third area is spatial audio part 2, which is the part 1 spatial audio part 1 in the area 1 is for the outer space. It's some reflector like the sound touch a wall and come back. But the spatial audio part 2 is about in a house or in a cube box, right? And you are making a room and how to connect different rooms. So this part is for that. And the first part is what we are going to focus on today. It's about custom audio plugins and audio analysis. But some people might know I was a sound designer. I'm not a programmer. So plugin. And
I think we're
right.
And I think that it's at that intersection, right, where Wwise provides this ability to do so much as a sound designer with no programming experience, and this ability to take it further through programming is, extends the workflow that a sound designer has at their fingertips without getting too dangerous on the game side and messing around with what's happening in the game engine. But I can't wait to see more about this. It's exciting. It's cool stuff.
Yeah. And also what I will talk about today is improvement. Like if you are a sound designer and how far you can go. And you don't need to worry how far you can go with Wwise, with PD, blah, 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 and everything. Yeah. And you don't need to code very good, but it's enough for you to do something nice.
Excellent.
So it's a picture from the last live streaming that about the plugin making, right?
Yeah.
And you can see here is some brutal DSP code. And when Samuel showed this DSP code, he wants more because he is a true coder and the mode is happy. And Michelle is a true coder and he's reading because he loves it. But for false coder like Matt and Damien, so scared and speechless. And for me, I don't want to see it, right?
I know. Seeing this is will turn people off sometimes right away. But in this episode 1 of the programming live stream series, we try to make it accessible. We try to make it easy to introduce people to the concepts. It looks scary, but what we tried to do was make it approachable for people.
Yes, it's already very clear, and I followed it, and I made my super gain, right?
You made the super gain along with us on the live stream. Great. Then I think we did good.
Yeah. So from the last picture, maybe you see those brutal code, right? Some of the sound designers might lose hope. Okay, this is not for me, right? It doesn't have the relation between a sound designer. A sound designer don't need to have this skill set, but don't lose hope yet. Like, you know what this is, right?
I know what it is.
It's our favorite toy, like synthesizer and modular. Some of you might have it and some of you not. But if you know synth, right, you know synthesizer and you can code.
Yeah.
Because we are plugin, Wwise is about audio, so yeah.
And it's really about patching things and routing things and connecting things. And so I get it. I get the analogy. If you understand the way that you can patch an oscillator to a filter to an envelope, these are the fundamentals of what you're going to cover today.
Mm-hmm. Okay, so next is let's welcome the gateway drugs of audio programming.
Yeah.
Those some people already played Eurorack. It's also a kind of a gateway drug, but PD and Heavy is the most strong ones, right?
Yeah.
But what is PD and what is Heavy is just the two icons and have no meaning.
Let's find out.
Yeah. So PD is from here is it's just a history. PD is something made by a guy called Miller Packett. He started everything.
And it's short for pure data.
Pure data.
Right. PD to us who've heard it before, but pure data to folks who might be just searching it on the internet.
Okay. Yeah, I'm sorry. Let's continue. And this guy is super clever, and he's a genius. And he joined an institute called AirCom at the year 1985, and I call this AirCom the lab. And at the year 2 years later, the first version of Max. Do you know Max? Max MSP. It's a language.
Yep.
It's a language for artists. So the first version of Max is born, and after several years, and Miller, who is the father of Max, just left Aircom, and he went to UCSD. I call it New Lab. And in this lab, 2 years later, and he just had another baby. It's called PD, and it's open source. And the PD was in the lab. It's not open for normal people. It's for genius. And so PD now is for everyone. But after several years, like David Zaccarelli commercialized Max, and this guy is the CEO of Cycling 64,
Mm-hmm.
and he just made Max better and better. So this icon is what we see Max now, right? Okay. So next slide is what is PD? PD is a high-level visual programming language. It's for artists, so artists don't like text. It's just like metrics. You see metrics, and it makes no meaning, and you just will doubt yourself. And the PD will, though it's still a bit abstract, but it's understandable for some artists. And it just like some people might work in Unreal Engine, and he knows the blueprints, and some people played with Reactor, and some of you might know the VC Rack. I think they are similar to PD. It's just a language. And what this language for? Sometimes it can do some general purpose calculation. Like even you use Eurorack, you can calculate +1 + 1 = 2, right?
Yeah.
And so it's all language.
And as we'll see later, you start to connect pieces of pure data using nodes the same way that you would connect pieces of a Eurorack, a synthesizer, or one of the visual programming languages like Blueprints and Unreal.
Yeah, and because we are going to talk another thing called Heavy, so if you want to work with Heavy, and you have to use the PD vanilla version. It's not because there are some other versions of PD. It's called Extend. Extend means that it has more function and more modules, more libraries, but PD vanilla is the cleanest one. So yeah, it works. I think the performance is the best, right?
Yeah.
For
exactly.
Okay, so next slide is what is Heavy, and yeah, it's a lot of information, right? And you can see here is a paper. The paper is called Designing Next-Gen Academic for Game-Centric Procedural Audio and Music.
And
anyone know procedural audio?
And I'm ringing on the telephone right now. I think we have a special guest dialing in with us. Let's wait for that exciting arrival. But Heavy is the tool that you're going to use to encapsulate that pure data patch that we're talking about.
Yeah.
And I'd like to welcome to the live stream Joe White. Joe, welcome.
Hello.
And through the magic of technology, we have brought in a lifeline from the UK. Joe White is here with us today on Wwise Up On Air. Thanks for dialing in.
Thank you very much for having me.
So I've known Joe a long time. Back in 2013, we ran in the streets of London during an AES conference together, and happened to know him and Martin Roth, the co-creators of Heavy, throughout the development. But why don't you take us back in time? Let's talk a little bit about what is Heavy, how that project came about, and yeah, tell us a little bit about that.
Yeah, I would just say I was watching the stream before I joined in, and I think I was in the past. So hopefully I've understood, how you started off with everything. But let me know if I'm going over ruined ground.
Latency.
But yeah, where we started. Well, I think our main interest in starting NZ in audio, which is no longer around, but we were really interested in kind of making a process to describe how we generate audio content at runtime while it's in the game, kind of while you're playing the game. Or but our background actually was in making interactive or kind of reactive music applications on the iPhone. And that was at a company called RJDJ. And we ran pure data as our kind of way to create the content, to get all the audio in, and then take all of the information and all the sensor data that you get on the phone, run it into pure data, and then just create cool experiences that would react to things that you would do in your life.
Yeah, and this was like, mobile-based Inception app. There was a Batman app, and again, these were experiences where they would take in and layer the music or sounds from these movies along with the ambient sound from the world and kind of process it according to, like the bus goes by outside and it gets all like flanged and stuff. And so really cool applications that really push the boundaries of real-time sound.
Yeah, I mean, we tried to, obviously RJDJ was out on the first iPhone that came out, and subsequent models, we were always trying to push the boundaries of whatever we could do. I think for a long time we was always running at 22 kilohertz, and at some point was like, should we make that switch up to 44, because now the new phone can run double the amount of power,
Yeah.
So like being able to kind of process like the microphone, like have effects processing and do synthesis and mess with waveforms and all that kind of stuff. We were always limited by the devices, and so that's kind of the start of the spark of where Heavy eventually came to was, how can we optimize the runtime component so that it's as fast as possible and it targets particular hardware and it will be optimized and run really fast so that then you can do more things. And that was the first thing that kind of Martin was working on, was Heavy's this way to kind of compile a pure data patch and generate a really optimized version of it it's written in kind of C or C++, and then you can just run it on any kind of platform and any kind of hardware. And that was the initial test where it came out as like, could we do it? And after it started working, we just kind of expanded on it, and it was then really interesting to see. I guess you could kind of think about it as like, like you get in kind of graphics where you might have a shader that describes how a pixel's colored or how the geometry should be positioned or shaped. We were kind of doing the same thing where instead of loading in an image that you just render in the screen, you describe a program then that generates the content, and then Heavy was essentially just optimizing that program.
Perfect. And at the base of Heavy is pure data. Pure data is the language you're using to describe that audio process, that behavior, and that became the fundamental of building forward. That became the fundamental component of Heavy that Heavy's based on.
We because obviously our experience with using pure data, we lent on that, but also there's a massive community of people that have been using it since like the 80s, I guess, and it made sense kind of as a tool that people were familiar with, and there was already a community, and we found it useful for like rapid prototyping of the techniques that we're trying to do, like kind of source generation or effects processing.
Yeah. Excellent. And so you built that forward into a pipeline for people where they could create their pure data patches. They could push it through the Heavy pipeline, which would break apart the components of the PD patch and kind of recombine them into various formats that could be used at runtime. What formats did it output to?
Yeah, so like you say, the input is PD, and then the core output that you'll get would be like a little program. But then we would wrap it in different frameworks that were already kind of available. So the first one I think we did was a VST. So you could just put it in a VST plugin, then put it in your DAW. And then we expanded it to things like just generating a Unity plugin, and you might have like an audio mixer plugin, or you might have a mono behavior wrapper so that you could add it then in as a game object into your game. And then one of the things obviously was Wwise plugins. So kind of it constructed all the framework around building a Wwise plugin, and we would take the information that was contained in the patch about the thing that you're making. For example, what kind of parameters, like how many audio inputs and outputs do you have, what kind of parameters are you using to control it, and then on the generated side, the Wwise plugin would then expose it kind of automatically. So trying to just reduce the kind of coding that you have to do, and also speed up the pipeline so that there's less friction in terms of designing your idea and getting it into the game.
Exactly. And we're gonna go.
And there's also JavaScript as well. Sorry.
Yeah.
So you can run it in the web. I always forget that.
Well, we're gonna go deeper into that pipeline as we move forward on the presentation. So where did Heavy end up? Like, where are we today with that? What was next?
So yeah, Heavy, it exists now as it's like an open source project. It's on GitHub. I'm sure Chenzhong has some links to it, but it's not supported right now, but it seems like there's quite a few people who are taking it up and digging into it, which is amazing to see. But yeah, it exists out there, and you can use it, and it's free.
Excellent. Excellent. That was an expert overview from Joe White, formerly of Enzian Audio, along with Martin Roth, who created the Heavy Audio tools. They're open source. They're a piece of this presentation, and I'm really glad to have had your overview today as part of our live stream.
Thank you very much. Yeah.
Yeah.
Good luck with the rest of it.
Good to see you again. Thanks for jumping in.
I'll see you soon.
All right,
Bye.
take care. Chenzhong,
Whoa.
that was fantastic.
Whoa.
Like, ta-da!
Okay.
And as you were, let's keep going.
It's the last minute I'm watching this picture, but then it comes in. Okay. Okay, nice. So I continue.
Yep, let's roll.
So I think everyone now knows what heavy is. When you combine PD and heavy, and you can see the whole picture. Like PD is something like a shader graph in Unity, right?
Yeah.
You want to build a texture, and you don't want to write the shader code, but you want to connect different boxes and to generate the shader. Then let the game engine run it. So PD is a shader graph, and heavy is it's some magic.
It's
between. So next picture is it's a compiler. So what is a compiler? Compiler is when you are creating something at a higher level, it's like you are writing C++, but you're writing C++, and you can understand it because you are a human, and but computer is not a human. Computer has to read 0 and 1. It's the matrix, right? And so if you want to build a plugin, and the plugin run a computer, and there must be something that is 0 and 1. But your code is not. So your code is high level, and 0 and 1 is low level. So a compiler is something like converts the higher level things into a lower level, and then it can be convert again, like it's a wrap into something that can run on Wwise. So if it's still complicated, you can see here is some magic and turn your rack into VST plugin.
Yeah, and I think of it as translating that higher level language of pure data into something that is lower level and accessible by different tools, VST, Unity, Wwise, etc.
Yep. So let's continue. So next is what can heavy plus PD do? I think Samuel have already talked about it. How many kind of PD Wwise plugin there is. Like we have source, effect, and sync. Sync is audio device, and for the effect we have in-place effect and out-place effect. But if you are using heavy and PD, and you can create a source, like you think, okay, Wwise doesn't have a FM synthesizer, I want create a FM one,
right?
not sense one. So you can create a source plugin, and then there is a effect plugin. Like what we are going to make is mostly effect plugin.
Right,
So,
and for a deeper dive on the plugin pipeline. In Wwise, you can find on our Twitch channel, on our YouTube channel, the Introduction to Wwise Programming, Episode 1. We go slowly through the process and through the understanding of this. But I think you explained it really well, Chenzhong.
yeah, thank you. And also like the PD and heavy is not only a signal processing plugin, and it can output some other things. Not only output audio, but output the game parameter. Like I think some people might think about how to create a LFO model, like LFO plugin inside Wwise, and use this LFO to control other things, and use RTPC to control the LFO. So though we have some LFO, but with heavy and PD, you can create that kind of thing. So sky is the limit.
Yeah.
And the next slide, yeah,
It unlocks a lot of creativity.
yeah. All you need is to learn PD. It's for artists.
That's all.
So here is a picture from Remedy, and they gave the talk several years ago, and maybe 2018. So on the Wise Tour, and they show the music system prototype. They created with Heavy and PD. So you can see the different blocks are different. I think different. In Wwise, it's a switch container. Like it's different for different function of the music. Some is for combat and stills, but here is something interesting. Like you can see this letter is very small, but it's R. R means receive something from Wwise, and when it receives something, and then it will send something out to control the whole system. So it's a combination communication portal between Wwise and your plugin. So it's here. So though it looks like complicated, but it's quite simple. Here is a sequencer, and the sequencer have some notes that's static. It doesn't change, but some notes are randomly change the velocity or change the notes, some parameters. So you can think it's just like a automatic composition plugin designed by sound designer and not programmer.
Yeah.
So yeah, I think it's pretty cool.
And this was from Control?
Yes.
Yeah.
From early Control prototype.
Right. And so this is really, the game talking to pure data through Wwise and controlling the music.
Yeah.
Music generated from pure data?
I forgot, but I think this is maybe a MIDI generator.
Sure. Great.
Yeah, it will send out some message, but yeah, anyway, it's just for
fantastic.
Okay,
great example.
Let's continue. So if you want to get heavy, and you can go to the GitHub and then Audio HVCC, and you can go here. Is click the button. So let's do something. Let's go. Okay. I will open this website.
This is exactly what folks need to get started with doing it on their own. And it's the magic of the internet makes this all possible, right? Let's try to cherish that and honor the internet when we can.
Yeah. Okay. So I will show you very quickly, and it's a project of a Heavy compiler, and here you can download the whole project, and you don't need to use Git, because I think some designers they like to download it directly. I just click here, and it will start download. So something else, like you have to install Python before,
yeah,
and also install the requirements, because I won't show how to do this stuff. I think you can do it, because your programmer is clever. So, and other things I will talk later. So here we have already downloaded it, and let's go to somewhere. Here is a folder. It's called Wwise Up On Air plugins.
Yep.
It's for this. Yeah, it's for this live stream, and here is HVCC master. It's on. I extracted from the file like I just downloaded it, because I did some prepare. So it's Heavy CC Max, and you open it, and you can see all these stuffs. And the first thing we are going to do, let's turn back to the PowerPoint. I'm sorry. The first thing is going to configure our template, because we are going to generate something, and there are some messages already written in the thing you have already downloaded. So let's go back. So let's go to the generator, and we found C2Wise. C2Wise is for Wwise, and here is the C2Wise.py. Let's open it with a text editor, and if you try yourself and you download from the GitHub, you will see that like the line 58, there is a Wwise SDK version, and you will see it still stays at 2017. So now we are.
Which was the last time Heavy was updated on Git.
Yeah. But don't worry, it's still usable. And then all you need is to change the SDK version number to the right one, and it's because it's here. Like I put my Wwise under this folder. It's a HDesk with Wwise for testing. Here you can see it's these numbers. You just copy it to here, then save. So that's all you need for this file. And then let's go back to HPCC. Here, let's go to the generator. Open generator, open the C2 Wwise, and here is the template. In the template, there is a VS 2015, open it, and you will see some files. It's a template of the Visual Studio solution, because Heavy will generate a solution to build your plugin. So you have to modify the solution so you can use it. And why we have to modify it? Let's open it with the text editor.
Yeah, and just one more time, like in that Programming a Wwise Plug-In episode 1 on our YouTube and Twitch channel, we talk about solutions. We kind of slow down time and step people through the process of what is a solution, what are the parts of it, why are they good, what Visual Studio do you need. So a lot of information on that other stream as well, but you're doing a great job going through it.
Okay, so like if you download the Heavy compiler, by default you will see this. It's some default location for Wwise when you install Wwise. But my Wwise is not here, right? And I have to change it to the place where my Wwise is. And here I just copy my Wwise location, but leave the Wwise version as it is, and the /SDK. So, but I have to modify the. It's a VCX project file. So all 3 VCS project file, and for the Wwise SDK path, I have to modify them all. This one is not mine. Sorry, let me check. Okay, this one, let me check if it's correct.
And if I can pull out for a second, I think, what you're doing right now is you're just making sure that Heavy can run as a compiler for the pure data patches that you're going to create. And when we say that, what we really mean is you're setting it up so that it can run on your computer. You can send it a pure data patch. It will process that and transform it and output a Wwise plugin. So you're setting it up so that it can do that job for you.
Yeah. And also, like, setting the right SDK version is ask the Heavy compiler to use the right assets, because if you're it's using some old assets and it will not work properly. So after we set it and all the preparation is done, now after you do the Python, the C2 Wwise Python, and also the project file configuration, and you are now having a working Heavy compiler on your machine. But something I want to mention, that before Engine Audio shut down Heavy, and there was a website. You can go and you can upload your PD patch onto the website, and for some configuration you did, and it will generate all you need, and you can download it from the website. But now the website is not there. But still, some people from the Rebel technology, and I think they implemented the compiler, the web compiler, on their website. So you can still use the online compiler. Like here, you upload your PD and choose Heavy and save compile. And when you see the compilation success, and you can download from this button, and you just download it. But there is a drawback because we didn't set the SDK version, also the Wwise SDK path. So when you open your project file, and you will see that the location is still old. Right, it's a drawback.
Yeah, so that's two ways to approach it, right? If you're looking for the easy path, you can use the compiler provided through the website that will give you immediate results, but it has the drawback of not being specific to maybe the Wwise version that you're using. And so it's maybe we'll give you quick results, and you can have some small success, which sometimes with programming, we just need a little bit of success. But when you start to go further, what the website does is it actually is a heavy build farm, right, that you submit pure data to, and it compiles and sends it back to you. Creating that locally using the process you described in Git means that you won't have to go through someone else's Git build farm. You'll have your own, and with that, you have the customization that you described.
Yeah. Like build your compile machine locally, and it will accelerate your process of iterating. Because if you use the web-based compiler like this, every time you generate the solution, you have to set all these things again. So it slows down your process. So after all the preparation, now we are going to make something. And yes, let's see. The first we are going to make is a BitCrusher. Is there any audience from China?
Yeah.
Yes. Yeah, some of them might already watch the video I uploaded to Bilibili, because I used this technique before, and I created a BitCrusher. Why I create BitCrusher, and it's because Wwise doesn't have a free BitCrusher plugin. So if you can create one, and it's interesting, right? And also, like, there is a very awesome game called Nier Automata from Platinum Games, and they use a lot of audiovisual glitch effect, because not only visual but audio, like when there are some glitch happen, and the sound is also downsampled or downbeat, so there are some extra noise. So it's super cool.
Well,
so I want to.
And as we'll see in your demo later, like when you synchronize those things, it's very powerful.
Yeah. If you only have visual, it's still not very glitchy. But if you have both, and it's cool. So because I want to show this to the China GDC, so I build a demo and added this kind of feature, and yes. And for the visual part, I used a shader from Kejiro. Kejiro is a very famous Unity guy. Everybody know him, right? He created a Kino glitch shader. So I use this shader on my camera, but for the sound, I have to create a BitCrusher by using PD and Heavy. And I want to write it in C++ because I don't know how to write in C++. Yes. So now it's a demo time, and I will show your demo. And because I have removed the BitCrusher from Wwise and Unity, now the authoring part of the plugin is not there, and also the sound engine part is not in the Unity project. So we will fix it. Okay. So here is the demo.
Awesome. So switching over to Unity, jumping right in.
I hope the sound is good.
Cool.
Let's turn on.
So great overview. If you have questions about what's been presented so far, drop it into the chat. We'll try to answer the questions. I saw one fly by, and we will kind of arrive there in time to answer that. But please send your questions into the chat, and we'll try to get to them.
Okay, so but it's stuck. I hope it won't stuck too long. And why?
Why? Because it's live, and this is always the way it works.
Maybe my mechanic disk. It's running on a ROM disk. Okay.
Yeah, well,
So
this is game development.
I will show you something like here. If I press, by the way, I'm using a Stream Deck. If I'm using a Stream Deck, I can go to some path or location on my computer very quick. So that's why I use it, and it's under the Wwise authoring plugin folder. So you can see, it worked. It worked. Let's check.
Ta-da.
It's fine. Ta-da. So I will talk about it. It's like you can see, it's all plugins. When you see HV, it's made by Heavy, and you can see those BitCrusher, right? There is no BitCrusher. So let's go to the demo. Now nothing is playing, and I will mute the music first. So if I start music, let's go to see something. Right, you can see those cubes. And if I put make music louder.
Yeah, I hear it.
Yeah, you can find that the cube is moving following the music. And the music is like a clock. When the music is faster, and the cube is faster, moves faster. Right? You can find it. So I just mute it, and you can see here.
And that's just simply scaling the size of the cube on the beat of the music.
Yeah. I will talk about it later.
Awesome.
And everything, how to do it in Wwise and Unity, and the code, everything.
Great.
So here you can see it's a glitch amount, a fader. If I put it bigger, every time you hear the cube is having sound, and the screen is just glitching. But there is a problem. Okay, so can anyone know the problem? The problem is the sound is too clean. There is no beat crashing happen. So if we want a really cool, really crazy glitchy effect, we have to make the BitCrusher work. So I'll stop the demo. Now let's go back to fix the demo. Here, it's on the screen. You can see it's my Stream Deck. The Stream Deck is a panel of buttons, and I created a lot of buttons so I can automate my workflow to build the plugin. And here you can see there are 10 steps. The first step is create a folder for your patching project, which means that if you want to build a BitCrusher, you should build a folder for your project. It's a serious thing, right? And you build a folder, like here I build a folder. And if I press this button on my Stream Deck, there is a folder just jump out. And the second step you can see is open PD and create your patch and save. So you can see here, there is a PD button. If I press this button, yes, I have PD. So that's why I use Stream Deck. Yeah, let me close it because I already have a PD open. So save, and I will open the patch for you. I already made it. So here is the PD patch.
I agree. It's nice to have an extra set of buttons. You can always create a bunch of shortcuts on your desktop, or batch files to do the same kind of thing. But having the extra buttons is great.
Yeah. It's not like the desktop, because every time you go there, different layers of folder.
It's true.
So, yeah. So sometimes you'll say, "Oh, I should read this PDF," and the whole day is gone. So yeah, you create your patch and save, and now the next step is open the HVCC folder, which is where is your Heavy compiler, and because we already set the Heavy compiler, right? The SDK version and SDK path. So I just go to the Heavy compiler. It's here. And then next step is pre-make solution for using your patch. What it means that I'll show you that if you want to pre-make it, you have to run the Heavy CC, and there are a page on the this page is a patch, and this page is on the website of the Heavy compiler, and there is a part called usage. Like if you want to use the Heavy compiler to first pre-make your solution and then build your plugin, there is a magic code here. It's so long. It's Python heavycc.py is running the compiler and my project. Blah, blah, blah. It's too many. I'm a sound designer. I don't want to read it.
Well, so, and that's the kind of thing you would have to open a command line for. You'd have to maybe type it or copy paste it. It invokes Python. It feeds it the arguments that it needs. Okay, but you're a sound designer.
Yes, and I'll explain it even more clear. Like because you have to run it on using Python and in the command line, which means you have to go into the metrics, and it's too many. So let's split it into several parts, like running Python, where is your patch is, and where you want to send the compiled solution to, and what's the name of your plugin, and which platform you want to generate. So because we are going to make the BitCrush, right? And like I have already created a folder for it. It's called HVCC BitCrush, and the path is here. So here is the path, like where I want to get my the main PD patch. Right. So here is the so here this string is where I want to get my PD patch. You can see it includes the PD patch, main PD, and the next one is where you want to send your solution to, and under the folder I've already made where there is a compiled folder. The compiled folder is for containing the solution. So yes, let's go back, and then we have this part, and give it a name. It's HCZ BitCrusher, and generate for Wwise, and combine all these things into this long string. And here you got your command for your machine. Because I don't use 2.7, I just use Python 2, so it's all I need. And then I put it onto my Stream Deck. Like here is a button, and I copy the string to here. This button is for pre-make my plugin, my BitCrusher plugin. So let's see. You can see there is also a button here called Open CMD at Location. CMD is command line. So let's go to the BitCrusher folder. No, not BitCrush folder. The Heavy compiler folder, and we just click here. Yeah, it selects the path. And I press the Open CMD at Location, which is type CMD, and then give it enter.
You can also just right-click in that field to open a command line there as well, can't you?
The shift, as I remember, open PowerShell.
Yeah.
Yeah. But let me use this old style.
But you should use your magic button. It's way cooler.
Okay, so we got this this window, and all you need is press the button you just created, which is input all this line here. It's all the things you need, and then enter. Okay, so what happened? So let's go back to the BitCrusher folder and open the compile folder. Something is here.
Awesome.
And
what that did is it used the template and created everything you need to start coding your BitCrusher plugin for Heavy.
Yeah, but you have already coded it because you made the PD patch, right?
Yep.
So Heavy compiled it or writes the code for you.
Great.
With your patch. So now you are already having your code. So let's open the Wwise folder under compiled, and there are something, and let's open the VS 2015, and now you have something just like the template you have set minutes before, right? We are setting the Visual Studio solution and the project. So here is a SLN, which means which means the solution, and I don't want to open it in the VS 19. So I'll open it with VS 17. Okay, so no upgrade because it's old, and some other things will jump out. Cancel. Okay. Now we have done, and let's see what's inside it. It's a code. It's
my eyes. Ah.
It's a code that's Heavy generated for
Chenzhong,
you.
help me! What is this?
Okay, but let's see something that you're familiar with. Like here, it's a patch, right?
Sure.
And you can see that there a name of the parameter is called sample rate division L and sample rate division R. So in the Visual Studio, and you can see that. So you find your place to land, where you should put your foot on. It's on the moon, right?
Great.
So here's the L and here's the R. So it means that the Heavy has compiled and made something that contains the parameter you created in your PD patch. And other things is some even more crazy stuff, and we don't need to read them. We just hide them. And select here and here, like let's go back to the Stream Deck. You know, I made a button just for press Control Shift B.
Perfect.
It's the build button.
Yeah.
It's the build button. So let's press the button. It's just you can do Control Shift B on your keyboard. It's the same, and yeah, the building process is running here.
Great. And so essentially taking that PD patch for the BitCrusher that you created, we use that Python argument to build this solution that we're looking at in Visual Studio right now. And then from this Visual Studio solution for that, you're building the plugin for Wwise.
Yeah.
Great.
And I think there is an analog way to talk about it. Metaphor, like you created your patch, PD patch. It's just like a recipe, and you are the chief, and you created a dish, right? And then you send it to the restaurant, to your assistant. Assistant is Heavy. It's called Heavy, and that guy called Heavy, and he just prepare all the materials for your dish, and then send back to you. It's a bunch of different files or things, right? And you are the chief, and you just put all of these things into a bowl and start to cooking it. So the cooking step is just the build, because the Visual Studio will connect all those files into something you need. So okay, so we already built successfully, and because the build configuration was debugged, and we want to build several different versions of our plugin. So let's build the profile version.
And again, a great overview of all of the different types of plugin versions as part of the Wwise Up On Air Wwise Plug-In Programming Episode 1. You can find it on Twitch and on YouTube at our Audiokinetic channels. We talk about the different kinds of plugins, as Chenzhong mentioned, the debug, the release, and the profile, why you would want one and not the other, what the reasons for them are. Absolutely dig in deeper there if you have questions about which one, why, and where.
Yeah, I have already built the release and the profile. So let's go back to the folder. Okay. BitCrusher compiled Wwise and VS. No, not VS. Here is a build folder. It's a new one. Let's open it. When x64, and now you have everything you need. Right? Let's open the release. So we have these 5 files. All the 5 files is all you need to deploy your plugin into the authoring tool and also the game engine. Because if you want to test it, you can put this tool into your Wwise folder with the authoring tool plugin, and this one is the sound engine plugin. It's for putting it into a game project, and it will run with your game when your game shipped, and it will run on player's machine. So now we are going to copy this tool to my Wwise.
And Chenzhong, what platforms will those run on by default?
Let's see.
Is it Windows? Will it run on Mac OS X?
I think iOS and Windows, Mac, even Xbox, but if I remember it right, but no Android, unfortunately.
Okay.
That's why some friends hit me because this is good, but not for Android. And Android is super important here in China.
Yeah.
Yeah. So yeah. But for some design and if you want to do something interesting, and only if you don't want to ship your game onto Android, you are shipping it on Steam. So Steam. It's good to have the heavy plugins. Yeah, so let's go back to here, copy this tool. Let's go to what happened. Let's go close it. Copy this to file, go to Wwise 2000.2.5. It's the version I used for my demo.
Yep.
And copy into the authoring x64 release binary plugins here, and Control V.
All right.
I hope it works, but wait, it's a slow disk. Yeah.
Perfect.
Okay, so
here, drop them into the Wwise plugin folder. Got it?
Yeah. So here is the Wwise project. Let's close it and open it again.
That gives it a chance to find the plugin that you just dropped in there and initialize them for the authoring application.
Yes, and we will do some tests. It's a BitCrusher, so here, effect, let's go find the BitCrusher. Is there a BitCrusher? Sure, it's here.
Awesome.
Okay, so in order to let you know I'm not cheating and I will remove it, let's go back to Wwise and see again. Because I didn't see, yeah, it's very quick.
We trust you, Chenzhong. We trust you.
Let's go. Hold on, and let's see again. Where is? Yeah. You see that step, copy and paste the step just made our plugin appear. So.
And if you're watching this, always remember the copy and paste step. Don't forget.
Okay, so now we have the plugin for the authoring tool, and we copy the sound engine parts and you put it into the project. Here it's a folder that my project is. It's the Unity demo thing assets. Let's go through it. As it's under asset. Start from here. Your project, assets, Wwise, deployment, plugins, Windows 64, DSP. Here you got this, but if you use the button, and it'll be fine.
So, and this is the Unity project location where you need to copy that plugin as well.
Yeah. And I just put it here, and let's go back to Unity, and I think Unity will generate the meta file. So now let's go back. Okay, that meta file is there, and then let's go back to Wwise, because
last step, right?
Yep.
Cool.
Because we already no, we already opened one. What happened?
That happens to me all the time.
So, yes. Wait. Oh yeah. We already have it. So now I add it to here. Let's open it. And you can see here I got the sample rate division L, sample rate division R.
Cool.
It's our plugin.
And those are the properties that you set up in the pure data patch. So you created those in the pure data patch, and through the Heavy pipeline, they've now been exposed as part of the Wwise plugin so that you can parameterize them, use a gain parameter to change the value using a RTPC.
Yeah, and here after the HV param, and you can see 4800, and it's a 48K. This one is a minimum value. It's maximum value, and it's a default value. So because the 48K is default value, so when we open the plugin for the first time, it's a 48K. And then because I will put something here, make SDK, so let some gain parameter to control the effect. So, but I will talk about it later. This gain parameter is called glitch detector, and here when the glitch detector happened, it's something has an amplitude. When the amplitude is big, so let's make the sample rate lower, right? So right click. I want to use a steep curve. Yes.
Awesome. So you're wiring in the gain parameter, or at least setting up the RTPC to get a parameter that we can use to change the bit crushing amount.
Yep. So if we want to test it, where is glitch detector? Glitch detector. Yes. Let's all play the music for a bit, and let's try it. You can hear that?
Yeah.
It's a happen. Yeah, we are creating something that not in Wwise. So is it exciting? So let's go back. Generate the select sound bank, because let's go back to the Unity. And now, because we already deployed the plugin to Unity, so let's go back, run the demo again.
And did you generate sound banks?
Yep, I generated.
Okay, great.
Okay, play music. And let's lower the glitch amount so nothing will happen. Yeah, we already.
And we're glitching. Yeah.
Right. You can hear the glitch now.
Yeah.
So.
And now everything's in synchronicity. That's great.
Yeah.
And so the only thing we didn't see there is that you had already established a gain parameter in Unity that was being sent to Wwise.
Yeah.
Great.
So that's the next step is
excellent.
How the visual part work. It's a whole system, and so that's why I show it at different time of the demo. So in Wwise, there are 3 cubes, and they all make sound. And for the cube, for each cube, there is a Wwise meter, and in the Wwise meter, there is Wwise meter will send something to a gain parameter, and where it gets the information, it's from the source file. When the source file have something happening, and the Wwise meter will capture the the volume envelope and send it to the gain parameter, right?
Perfect.
Then the gain parameter will be read by Unity. So the next picture here is like the music center. Here, play music center is an event. When the event play the sound, it will specify where to play, and it will play on the cube, right? And the cube made some sound, and the Wwise meter will capture the volume envelope, right? And it will happen in the Wwise sound engine, and then the value will send to here. It's an envelope follow center. Yeah, and this value will be sent to the code, and it's here. There is an API called get RTPC value envelope follow center, right? For this line is to get the volume signal from Wwise to Unity.
It gets the value of that meter in real time as the sound is playing through it, and uses the volume level to modify the scale value in Unity for the block.
Yeah. That's the next step. And this API will have an output, and it will output the RTPC value center, and it will send to here, and here. And it's for this line. This line is for controlling the scale, the local scale of the cube. So when there is a sound and it's now silent, and the sound will and the cube will become bigger. And if the sound is not playing and the cube is the minimum size, and when the sound is loudest, then it's 5. It's the biggest size. So that's the whole system.
It's super cool, and again, leveraging the Wwise meter to send that volume as a parameter to the game that the game can use. Updating that value on the object in real time, using it to change the size. It's just a cool way to build a bridge between Wwise and the game and have this dynamic relationship in the same way that you're doing it with the BitCrusher. This is also a dynamic relationship.
Yeah. The BitCrusher is the next part, and like if you have some sounds that can cause glitch, like the cube, the sound on cube is this kind of sound that you want this sound to create glitch, and also the drum loop in your music is also creating a glitch. So they are all in this category, and you send all these sounds to a glitch bus. It's a bus under the master audio bus, and it will send send aux send to an aux bus called a glitch receiver. It will receive those sounds, and because there is also a Wwise meter on the glitch receiver, so the Wwise meter will send the envelope to a gain parameter. That's what we did on the master audio bus. And if we got a glitch detector, we will put the glitch detector to control the heavy plugin on our master audio bus, and also control the visual effect, because we have the glitch shader on the camera, so they happen at the same time. So when you have it, and it's a system. So, yeah.
Yep. So you're using that parameter to influence both the glitch amount on the sound from the heavy plugin that we just created, as well as using that same parameter to drive the visual glitch amount in Unity.
Yeah. So next step is demo review, and because if we can do review, and you get the whole idea. And let's play the music and open it. Yes. So you can see there is here. It's a analog glitch script, and these 4 parameters is controlled by the volumes information, right? Every time there are some sound, and you have this visual glitching, and because we already have the BitCrusher plugin in Wwise, so we are having the audio glitch. That's all, and we will go to the next part. This is the first plugin we made. So
yeah, I want to take a breath on that, because I think you know, you had this idea like, I want to do this bit crushing, I want to apply this to the sound, and I want to use the heavy pipeline to take this pure data patch and bring it to Wwise as a plugin, and use it to modify parts of my sound. This was the idea, right?
Yeah.
And from there, that realization that that glitching the sound was cool, but also bringing the visual glitch into it and synchronizing those made the effect even more powerful, right? Because now not only was the sound glitching, but you had this visual element to it as well that reinforced the sound of the glitch that you were applying. So, I think it's just with that inspiration that really probably set you off on this journey of, how can I accomplish this? How can I achieve this goal? Because, well, there's no BitCrusher in Wwise. So the ability to extend what's available in Wwise, again, you're using the Wwise meter, you're using the music system, so you're using Wwise, but then extending it through the creation of a BitCrusher plugin, and how it's tied to the Unity project that you created. That is the result of that creative idea and inspiration. I think it turned out really great. It's really cool.
Thanks, Damien. And I think because sometimes like audio designer is the sound guy, it's a hidden place and do some sound. And if we want to make an impact in the team and sometimes show some crazy stuff, and maybe it's good for our work. So I think maybe we should like define ourselves more like a game designer or game developers. Sometimes it's good. Yeah,
it brings a greater level of synchronicity between the game, the visuals, audio, all of the different aspects. And it's that kind of idea that elevates gameplay and sound to a place where they feel linked in the best way.
Yep, thank you. So next page is what we can do if we only have very basic pure data skill. No problem, because pure data has a lot of modules. Like the VCF is a filter, and because we have the in Wwise we have I think in Wwise we have this thing. It's called low pass filter, right? But we don't have the resonance value. So but with Heavy you can super simple. You just create a patch like this. As dumb as possible, and you will get a filter with res. It's just as simple.
Nice.
So, but I will stop here, and I won't go to deeper universe. So next part is creating FFT.
Wait, what's an FFT?
FFT is a faster Fourier transform. It's something like you can think it's when you see something happen and on your device, this sound display device, it's about the amplitude, and you don't want it to be the amplitude only. You want to see what the content inside of this audio. Is there some high notes or low notes? Because amplitude is just like you push your paper cone on your speaker forward, backward. It's about amplitude. It's further and it's louder, but it's two sides of the same thing. So it's a converter between two sides.
Great. So you're going to use the FFT to get the frequency information from the sound.
Yeah. Why I get this? Because I want to get more parameters to control the visual, and then we can create these things.
I know. I love this. I love this demo, and if you're following along, this gets super cool. Let's dive in.
Okay, so I'll be quick. So this picture is Kejiro Takahashi, who is the best Unity guy, and I don't.
Yeah.
But he's awesome. Yeah, and he's doing audiovisual live performance. So I think okay, he used Unity to do audiovisual performance. So I should do the similar stuff by using Wwise. Why not?
Perfect.
And luckily I did it, and you can see on the picture, and this is the first area of the demo, and let's go back to the demo. Let me see. Yeah, let's go back to the demo. If I should reduce the in the demo.
Flying through your demo right now to the fourth area of the demonstration.
Yeah, this area is you can see something like the cubes is jumping with your music. If your music is quicker and it's slower, right? You can see that the cubes jumped with your drum loop. So and if you want to go crazy and increase the glitch effect and also enable the 8-bit mode. Yeah, it's fancy. It's interesting. I love what I did.
Yeah, and so that's taking the different frequencies from the music and using it to scale the columns that are happening.
Yeah. Scale the scale Y of those cubes. So the louder, the taller of the cube.
Yeah.
Right?
Yeah, exact. So it's using both frequency and amplitude to drive the cube size and height.
Yeah. I will talk very quick.
Awesome.
Okay. So the next page is let's start from this again, but I've already explained it, so let's go directly to the patch. Here is the patch, and for the patch, it looks fancy like some dynamic stuff, but it's very simple. Like here, ADC and DAC, it means that there are some signal from Wwise, and then send out to Wwise. So it did nothing, but just let the signal in and put the signal out. But why it needs some signal and why it's through LR, it means through all the signal to somewhere, like to here.
Yep. So that little piece of the pure data patch is just the input and output. Sound comes in, left and right. Sound goes out, left and right. And this big web of wires in pure data is what you do in the middle of that small block in the graph.
And you have this BP unit. What is BP unit? It's a bandpass filter. And each of the block is a bandpass filter. And why I use bandpass filter? And also because you have bandpass filter and you can set the frequency, center frequency, and the Q. So here there is a loud band means that it will send a band to these message blocks and send out those message. So this is for setting all the 20 bandpass filter, setting the center frequency of all the bandpass filter. So it, and after the process, and those bandpass filter also output something out. but this is not audio signal. It's some values. Those values are what you get from Unity. These values will send to Unity and determine how tall your cube is. So that's the whole system.
So do you have 20 cubes?
Yeah.
Okay, so there's 20 cubes in Unity.
No, not eight cubes. I didn't use 20.
Okay, so you used 8 of the bandpass filters from this patch, and you're using the value of that frequency band to drive as a parameter, using that to drive the height and amplitude of each of the cubes.
Yes.
Great.
Yes, absolutely. And the next part is inside the bandpass filter. It will let the audio in, and also you can control the center frequency. But this one is already controlled by those message blocks. So for each bandpass filter, they will have different center frequency. Also, like the Q you can set, because here I exposed a Wwise parameter to Wwise, so we can use slider or RPC to control both the Q and also the gain. I want a silent plugin, which have no audio output, so I can use this gain to control it. And also here is a clock. What is clock? Clock it means the frequency you want to capture the value, the amplitude value. So how frequently you get it, you can control it here. It's a clock, and if the clock is faster, and you get more value and send out more value. So the spectrum data will be more detailed. So it's a BP unit. What's the BP unit work?
It's kind of the sample rate, how often it samples the frequency spectrum.
Yeah. But because if you are working in a sample rate, it will be costly. I don't want to do that costly because we just get some numbers. So I use this the metro. Metro is like a metronome.
Perfect. Yeah.
It clicks. After some time. So let's go back to build it. It's all the same process, generate the string by human and copy the string. So let's go to the FFT folder. FFT folder is here. You can see both patches here. Compile is empty. So let's go to the heavy compiler and put not this string. Let's run. No. Sorry. And heavy compiler, CMD, where is my CMD? Here, and run the line, and enter. Okay, let's go back to the compile here, OpenWise, here find our solution, open it with the VS 2017. Yep. We will build only one version of the plugin this time.
Keep it simple. Just the one we need to show it, yeah?
Yeah, it's going to late and release, build, boom.
So a comment from the chat. Someone has been trying to use frequency bands to analyze and calculate the tempo of streaming music. As an interesting method. There's also a question in there that I'm wondering, once we get this pushed over, can we profile the plugin CPU percentage? Are we able to get metrics about how much memory our heavy plugin is using in Wwise?
Yeah, sure. I will show you later. And I just copy the authoring plugin here.
Yep.
And also I think I already have it. So yeah, it already worked in the game, right? So let's go to the. So I just go through these steps because we already had the effect happen in the Unity. So it's for the demonstration purpose.
Good demonstration.
So let's go. Yeah. So let's go to the next part. How the visual part works. It's because we only let the FFT work in the first area, right? It's the area with cube. So I put the effect onto the loop here. It's a playlist for effect, and there is one called OBG FFT. It's the old version of my FFT. So I just bypass it and run my okay. Let's reopen Wwise. Open it. Yep. Come on. Okay. So loop bypassed, and the FFT here. Nothing you need to set. Just open it, and you will see this gain multiplier Q and yes.
Great. So those are parts of the patch that you authored in Pure Data that are now exposed in the Wwise plugin that you can adjust. But otherwise, then you have everything you need.
Mm-hmm. And also, like here is some output parameters. It's something interesting, like all the output of my patch appeared there. So I will set this one to a smaller value, and let's check the RTPC, and we can see I made some dummy RTPC here. This RTPC won't change the volume and won't change the makeup gain. It's just for some other purpose. I will show you later. And yeah, here like we have those BPs in the plugin, and we have to create the BP the gain parameter for all this band pass filter. And then let's check if we can make this gain sync. Yeah, here. So let's go to the profiler and the start capture. The demo area is 4 inside, and let's play. Yeah. Okay, so you can see here, right? Here is all the bandpass filter. The gain parameter has been set RPC value. So it means that our plugin is working.
Awesome.
And if we go to this amazing game object view and play the music, you can see our plugin is jumping just like some Windows Media Player visualization.
Yeah, yeah, it's cool. I love the new game sync monitor and the way that it displays all of the RTPC values on the graph. And as you said, like these yellow lines represent the amplitude and frequency of the different bands from your Pure Data patch. And so what you're doing is you're actually translating this two-dimensional flat graph of parameters into the 3D representation of your cubes.
Yep, that's what I did. So it's all this plugin is about. Why I do this is because we don't have this thing in Wwise, but it's simple in Unity, because Unity have a function called get spectrum data. But if you are doing this like get different band, the amplitude of a different frequency band, you have to create a lot of auxiliary bus and with EQ and with Wwise meter. So it's not the right way to use Wwise. So that's why by using the PD and Heavy is a good choice. I think it's a good choice.
Yeah, it's excellent way to get what you need into Wwise, where you then can use it to do whatever you want.
Yep. And here is showing what is going on in Unity. Like it's still get RPC value and like BP 0 and a string. The string is which cube is it, and you just set the value to the corresponding cube, right? Just send the value to the scale. Yeah, that's all it happened,
Awesome.
why it happened. So I think we don't need to review it because it's quite clear.
I like it. And again, I think it's this idea of trying to, empower your workflow so that you can leverage that frequency data. Again, knowing what, as a sound designer, knowing the goal that you have in mind and why you want to accomplish something is the first piece. Like, the second piece is, how can you accomplish that? How can you do that? And there's many times, as you mentioned, some tools like Unity have this available to you, but in this case, in order to leverage that inside of Wwise, you're using the pure data and heavy pipeline to get that information, to use it in a creative way to enhance the game and interactive audio that you're making. It's great.
Yeah, thank you. And if you want to go in further, and there is also a heavy library and a lot of like different modules if you play Eurorack and some VST plugins. And I think Engine audio people already implemented them by using the vanilla version and the write blocks from PD. So it can be compiled into some plugins. And also I want to mention that like here I put all the like PD modules, PD blocks into this panel. Like general, when you see some red stuff, it means that if you are using this like value or list or make file name, and when you compile, there will be error because Heavy doesn't support that. So and by the way, I wrote 2 articles about Heavy and PD, and if some people have interest, you can read on the Audiokinetic website.
We'll get links to those blogs that you've written, as well as the location of the introduction to Wwise plugin programming into the description. So absolutely dig in deeper. Again, those blogs are a great way to access the information differently. You do a great job of going step by step through these things. It's great to have those.
Yeah, thank you. So and if you want going even deeper, you can read books. And this book is the father's book, and this book is from Andy Farnell. It's a great book, and it's talk about doing sound design by using pure data. And if you can create those patch and compile it into Wwise plugins, and you will have a lot of audio objects, and you can even sell them, I think.
a lot of great creative examples, like you say, like the patches in the Designing Sound book. Very creative and approachable book for a sound designer who is interested in synthesis and procedural audio.
Yeah. And also this book is also great. So the next part is not about PD. It's about something I have huge interest about my music system of my demo project. And and where is my inspiration comes? Damien, you want to say?
I think we call this the bonus round, right? Where we get to talk about more fun stuff.
It's a where I get the inspiration is from again from Remedy, and Remedy is my god. and on Wwise Tour 2018, and they shared about how to generate the MIDI segment by using Python. And I think it's so cool. And the music system is connect different particles of the percussion music into a system, and you can determine the meter. So I think it's awesome. But I'm not a real coder, and even Python I'm not very good at. So yeah, I have to find other ways. But let's see the demo first. Where is the music? Play the music. Let's make it slower. Yeah. So each area will have different music content, and your gong is an instrument, can play notes. And the note is in the key, and also okay, let's go to the.
So each note is in key and it plays a scale.
Yeah, it plays a scale in corresponding to the area. So okay, so that's it. I will show the detail.
That's awesome.
Of the. Thank you. Of the system, because I'm not a coder, so I have to use some non-coder tools. So there is one called OM. It's all called OpenMusic, and it's for some computer assistant composition, and it's also developed by Aircom at maybe 1990, yes, and it's very cool. And for my demo, there are 4 areas, and each area have when I want to design the music for this 4 area, each area will have different scale. Like the first area is a C Dorian. It's you'll see the note in C Dorian, and the next part, next area 2 will have a G on C, which means C D G B. It's 4 note, and the next area is C Lydian. It's C D E F sharp G A B C. Yeah. And the last part is C major pentatonic. It's a peace and love, right? And 5 notes and no no spicy note. So but because I want to make the variety biggest, have the biggest variety, so I have to make a lot of random tracks. And so I have I created 2 layers. One layer is the melody tracks, and another layer is a bass track. And so if you have 16 melody and 16 bass, and you will have maybe 256 possibilities. And also like because we have a gong, right? The gong is playing the stinger, so we have stinger tracks. 1 track, 1 MIDI note. So you know that we have so many tracks, maybe 184 tracks. If you write it and export from DAW by hand, it's a nightmare.
That's a lot of MIDI notes. And again, what you're doing is creating this system of music inside of OpenMusic, exporting the MIDI from that system into Wwise, and then using Wwise to play back MIDI in conjunction with the sample banks of audio in real time in your demo.
Yeah. I will show the detail. So this picture is a patch, and looks scary, but here is for generate the stinger, like one note MIDI file, and this is for setting the scale of the mode, and this part is robot. You can think it's a random worker runs through the scale and sets the index, random index. But because the random worker sometimes will have duplicated index, so we have to remove it. And I have some remove the duplicated note modules. Here is for that purpose. And here is something interesting, like because I have the melody layer. Some of the melody layer is only have 1 voice, but some of them might generate code, because sometimes you have notes, sometimes you have code. It's more interesting. So I use this part to generate, to sometimes make the note like 1 note in 1 group. Sometimes there's 2 notes in 1 group, so you will have interval or single note. So this part is just for preview, and this part is for setting the it's for 4 beats or 8/4 beat, and it's for preview, and this part is for generate MIDI file. I will show you the process. Here is a patch. here is a folder. The folder will display what have been generated in the OpenMusic.
Yeah.
If I select here is MIDI generator and I press V. V means evaluate, and you can see here something is changing. It's slow, but it's doing something.
Cool.
Yeah, because I let it generate a lot of notes.
Well, you want all those variations so that you don't hear the repetition, right? So that as it's looping, it's always different.
Yeah, the more MIDI file you have, and the more variety you have, and also because MIDI is small, it's cheap. So what? Yeah, it's here.
Great.
Now we have these MIDI files. It's all generated from here. So
OpenMusic was basically going through the process of executing your system, composing this MIDI file, and from that, then it dumped those MIDI files into the folder for you.
Yeah. It's for the MIDI generating purpose. So let's go back to the project. And here I will show you the whole system and something I used. Okay. Here, the whole system looks like this. It's the top level of the switch container, and have different playlists for different area. And when you select the track, and you can see that I have 2 tracks, means 2 layer. It's a random step layer for the melody, and you have 16 tracks. And for the bass, you have 16. And it's so simple because you just press one button, you get 6 tracks. And also here is an entry bell, which will trigger an event queue, and it will play a music segment here. It's called entry random bell. Have a lot of audio files. I will talk about it later because generate audio is also interesting. And also here, it's a single note stinger, which triggered by the gun. Every time you are in an area and you fire the gun, and you will get the randomly selected from one note.
Got it.
It's something similar to Animal Crossing.
Yeah.
No.
Yeah, and how does it manage the key signature of the music?
The key signature, it's in the OpenMusic.
Okay.
OpenMusic. Yeah. Here you set here is 0 is C, and 3 is E flat. so you set it here, and you can put some offset.
Okay.
You get the key signature.
And the scale that the stinger plays in, you had that's a per room scale, right? So you have a group of stingers for each room that play.
Yeah, I will show you. There's stinger area 1, this stinger area 2, this.
Yeah. Okay, great. That's it.
Have different. Yeah. And also, I want a 2 octave box. Right, the area 4 is a pentatonic scale. So if it's 2 octave, maybe you have fewer MIDI note to choose. So here is fewer.
And those are arranged. The stinger is arranged in a music switch container. So
stinger.
When it plays the scale, is it playing in a sequence, or is it random?
It's random. It's a random.
Okay, great.
It's single. I don't want it. Some logic. Random is good enough because it's diatonic and it sounds okay.
Awesome.
Yeah. So the next thing is that I use the sample instrument I created, and also because there is an 8-bit mode, so I also put some Sense 1 into it. Yeah, and
cool.
Also I choose the triangle wave for the bass because I have to set the MIDI map, and I used Bernard's great Waapi script to generate all these things. So it's all here. It's all the MIDI, and I use some common public domain samples.
Sure.
So
And what you were talking about, Bernard's Waapi script, this was covered on a previous Wwise Up On Air hands-on where we went deep into the Wwise authoring API with Bernard Rodrigue from Audiokinetic, and he showed us a automated pipeline for setting up your instruments in Wwise.
yeah. Setting up the MIDI map here, because if you want to set these values by hand, it's crazy. Like you have a piano and you have different velocity layer 5, and
It's a lot to do.
400.
Yeah.
Yeah, it's crazy. So Waapi can do that just by one click, and everything is done.
Great.
Yeah. So next thing is the stinger generator. This is very interesting. Like here, I opened with it's Ableton Live, and I want to play it. It's not a project. It's just a instrument rack, and I have my sequencer, which is OpenMusic. It's my sequencer. Like here, if I select this preview window, I press V, and it will generate crazy, impossible music for me. And every time I press, and it will generate. If I press space, I can iterate different stingers. It's a stinger generator.
Hey, that's fun.
Yeah, it's a nice sound. If we want to create some crazy, like diminished scale, and let's see if it works. And yeah, and if we want to make the music longer, and okay,
I love it.
So that's what happened in the project. Here there is a random track with this hand-picked samples, stingers. So every time the music plays to the entry queue, and it will play this random music segment. And also it's controlled by RTPC, and to control the time stretch. When the music is slow, and it will be stretched. So it's
awesome. And because you're time stretching with MIDI, you don't have any of the time stretching artifacts that are there when you're time stretching audio. Is that correct?
This one is audio.
Oh, okay.
Music system, only this one is audio, but the piano is sample and also synthesizer. So let's listen to it again, and I think I'll finish my talk.
Awesome.
Yeah,
this is great.
Let's go to the first area.
And if you're in the chat room, drop us any further questions you have about the music system, about the fantastic multi-band analyzer, or the BitCrusher. Drop us a question in the chat. We're rounding up soon, and so we'll try to answer any questions you have. Let's hear this demo.
Okay, so let's put down the music, the sound, and the instrument. Yeah, it's slower, and yeah, you can hear the stretched sample. It's random generated. And we can put the music faster. Yeah, because we have lots of MIDI, so let's go to the second area. It's too quick. Cool. Okay. I think that's all.
That is totally cool. Yeah.
And yeah, so the final, yeah, that's full screen.
Oh,
Yeah,
nice,
I did it.
nice work. And like we said in the beginning, this is a demonstration that you built to help illustrate some of the ideas that you've been speaking with other developers about. It helps you show what is possible, not just within the confines of Wwise authoring, but when you push out on the edge of what Wwise is capable of, there's even more that Wwise can help you enable when it comes to creative integration of sound with the game engine. And like you said, this is a great way to be able to explain it to someone. Again, show and tell. And it really started, I can see, with these ideas that you've had about how to communicate these cool things. As a sound designer, that you've been able to accomplish these what I would call pretty advanced techniques. I think there's a clear reason why we have you as a product expert working with Audiokinetic in China. A huge value to people who are using Wwise, and it's great to be able to show what you've been working on.
Thank you. I'm happy.
You did great.
Rock and roll.
Yeah, rock and roll.
Yeah.
Excellent.
So
Fantastic. Had a bunch of folks in the chat applauding here at the end. And let's see. So, new fan of the series. What's the schedule? When is the next Creating a Wwise Plug-In episode 2 coming? Stay tuned. Get subscribed to our Twitch or YouTube channels and stay in touch through that. You can also sign up for our newsletters at audiokinetic.com, and we'll keep you posted on when the next episodes of Wwise Up On Air are going to drop. We got some fun stuff coming up for you, and we'll be excited to talk more about it. And so I got one last question coming into the chat. Event IDs. When event IDs from the game don't match, creating a new event in the game. The possibility of connecting the game to Wwise. Simply put, replacing ready-made sounds in the game with your own. So this is a question that goes way deeper than we're going to cover here. You're wanting to know, how do you recreate a Wwise project for a game that already has sound? And yeah, we're not going to go there. Too deep for us today and not related to this episode, but I thank you for your question. Thanks for tuning in. I would say at the end, Chenzhong, thank you so much for being a part. Thanks to Joe White and Martin Roth, formerly Enzian Audio, the creators of Heavy. Pure Data community for their support. Yeah, thanks everyone.
Thanks, Damien. Thanks, everyone. Thanks, Audiokinetic.
Yeah. Okay, great. So signing off, and we'll see you next time on Wwise Up On Air.
Yep. See you.